Security versus privacy, or privacy as payment. Prior to the proliferation of smart devices like IoT devices, smartphones, personal digital assistants or PDAs, etc., usually if a consumer wanted software for a particular function, an application or app, payment was made monetarily, that is, with currency. Now many apps can be downloaded for free. Now consider how free translates. In exchange for free apps, consumers now pay with personal identifiable information, or PII. Personally identifiable information, also known as PII, is collected by IoT devices and applications, usually when the user uses them or logs onto them in some fashion. The information that's collected by the device or application is usually name, addresses, which may be home or email, telephone numbers, locations, possibly username and passwords, and possibly date of birth. Security considerations. The following is a list of security measures that should be considered when developing and deploying IoT devices, according to Icon Labs. Secure boot. To verify firmware has not been altered using cryptographic code that is signed from the manufacturer to validate code integrity together with hardware support. Secure code updates. Using signed code to ensure malicious code isn't introduced. Data security. To prevent unauthorized access to device and encrypted storage communication. Security considerations continued. Authentication using strong passwords should be used to authenticate access to device, as well as authentication protocols such as X.509 or Kerberos, etc. Secure communication to and from devices using encryption, for example, SSH or SSL, etc. 40-bit encryption keys is no longer considered secure. Protection against cyber attacks using embedded firewalls to prevent packet flood attacks, buffer overflow attacks, and known protocol exploits. Firewalls prevent attack by allowing only trusted communication. And the third and final part of our security considerations recommended by Icon Labs is intrusion detection and security monitoring by reporting and tracking invalid logon attempts and other potentially malicious activities. Embedded security management, allowing the facilitation of updating security policies, thus mitigating known threats. And finally, device tampering detection to see if the seal on the device enclosure has been broken or modified, which may allude to tampering attempts. Some new processor board designs include these features. In conclusion, by the year of 2020, there will be approximately 50 billion IoT objects in use. We will have higher requirements to IoT data storage performance. How to optimize our data storage solution and how to protect our data securely. They are always important questions when we think about IoT data storage. In the future, we need more research about optimization of cloud data storage on IoT data. Fog computing permits IoT devices to run in more time-sensitive settings. Fog computing affords us a level of reliability that has been missing in the IoT. By placing data processing services on nodes physically close to the IoT device, we can avoid public network traffic, thus reducing the time it takes for a device to get a response for an application programming interface or API call. We must, at the very least, be a part of the solution and try to promote the responsible development and use of technology which safeguards our security and privacy. The future of IoT lies in standardizing the protocols used across the network stack.